Something in the sky screams for a thousandth of a second, then goes dead. Then, days later, it screams again. Not random noise, but a repeating, furious blink from across the universe. Those blinks are called fast radio bursts. They arrive like cosmic gunshots. For years, they were the universe's best-kept secret. Then one of them started behaving like it had a schedule. At first, astronomers thought FRBs were one-off fireworks, a catastrophic event, gone in an instant. Then a stubborn one kept returning. It came from a tiny, distant galaxy, and it wasn't alone. Some repeat with bizarre patterns. One even hinted at a 16-day cycle, a pulse of activity followed by silence like a clock that sometimes skips a beat. The surprise got sharper. When astronomers trained the most powerful telescopes, they found traces in the signal that shouldn't exist in ordinary space. The waves were twisted, polarized, drenched in magnetic fury. That's a fingerprint. It pointed to one kind of object, the most extreme compact stars in the universe, magnetars. Imagine a city-sized star with a magnetic field trillions of times stronger than Earth's. A mistake in the star's crust, a sudden reconfiguration of the magnetic field, and a thunderclap of radio waves rockets into the cosmos. Then the universe handed us proof. A magnetar in our own galaxy erupted and for the first time produced something that looked like an FRB. The line between theory and reality blurred. We had a culprit. But the story didn't end. If magnetars make FRBs, why do some repeat in elegant cycles? Why do others erupt once and disappear forever? Why do a few sit next to mysterious, persistent radio sources that hum long after the burst? And why do some bursts show signatures too extreme for known magnetar models? The mystery escalates when you consider distance. These tiny blips pack as much energy in a millisecond as the sun makes in days. We are seeing extreme physics at new scales. That opens extraordinary possibilities. Maybe some FRBs are newborn magnetars in turbulent birth throes. Maybe others are neutron stars interacting with dense material or companion objects, producing a lighthouse effect. And yes, for a moment, minds wander to deliberate beacons, a signature of intelligence using narrow, powerful bursts to shout across the void. It would be the most dramatic news imaginable, but nature keeps throwing plausible, messy alternatives at us. The emotional truth is simpler and more profound. We are listening to a universe beating in ways we never expected. Each burst is a message of extremes, magnetic fields that twist space, matter crushed beyond recognition, time measured in milliseconds. And every time we catch one, we pull back a corner of cosmic mystery. This is the golden age of radio astronomy. We are mapping a new language of the cosmos. If you want to watch the universe speak, stay curious. Subscribe and share, because these tiny blips might rewrite how we understand the sky.